So in this lecture, we'll discuss about Algorand's consensus mechanism, and this uses a mechanism called PPoS, which means pure proof of stake. Basically, this mechanism makes use of Byzantine agreement. Okay, so where this choice of adding the new block is directly proportional to the stake in the system. The stake in the system is representing the number of algos. And the main key features of this algorithm is there are no lock tokens, there is no punishment, and one token represents one piece of voting power. Okay, and this is carried out. Okay, the entire consensus is carried out in 3 steps. One is proposing the block, second one is soft vote, and the third one is certify vote. So let's see this. So one account is first chosen among all the accounts to propose the block, and then there will be a committee to decide or to perform a soft vote on the proposal. And the third step is again a new committee is chosen in order to certify that particular block. So you can see here proposing the block is the first step, second step is soft vote, and the third step is certifying the block. Once the block is certified, then the block will be returned to the blockchain. Okay. Yes, coming to block proposal phase, here VRF is executed on every participating account. So what is meant by VRF here? So VRF represents verifiable random function. Okay. So let me write here. VRF indicates verifiable random function. And this VRF is a weighted lottery system. So in this, the number of algos in the account will be directly proportional to the chance of account being selected. So it means if the number of algos in the account is more, then there will be more chance of getting that particular account being selected. Okay. So once the account is selected by the VRF, these nodes are propagated in order to propose the block to the VRF output. So you can see here after running lottery, okay, so once you select the account, okay, and once the account is being selected, you can see here nodes are basically propagated to the proposed block and in order to produce the VRF output. Okay, and finally you can say that particular account is a valid proposer. Okay, now consider the soft vote phase where you will see multiple proposal messages are circulated among the network nodes. So the main purpose of this particular phase, that is soft vote phase, is to basically perform filter operation. So what is it going to filter? First understand here. So there will be multiple proposal messages, right? The idea is to basically filter multiple proposal messages to bring down to a single proposal message. Okay, so filtering multiple proposals to single proposal so that it can guarantee only one block gets certified. Okay, and then coming to this, here what happens is every node in the network will be getting many proposal messages from the surrounding nodes. Okay, so the idea is to verify the signature of the messages and then validate the selection using this VRF proof. Okay, so clearly we are validating with the help of VRF proof, and the node will be comparing the hash from each of these validated VRF winners. Okay, and identifies the lowest block proposal. Okay, So this is nothing but it will identify the block which is having the lowest VRF hash. Okay, identifies the block with lowest VRF hash. Okay, and once it is identified, then obviously the proposal is propagated. Okay, so the next one is certify vote phase. So there can be some problems that you can encounter in the previous stage, like overspending, double spending. So here the committee is going to check the block proposal. Okay, so if suppose everything is fine, then it is going to certify the block. Okay, just like in a similar manner what we have seen in the soft vote mechanism. So similarly it is done in the certify vote also. Okay, but it just checks the block proposal that was voted in the soft vote stage for overspending or double spending. Okay, this type of problems it will check, and finally it will certify the vote. Okay, so certifying the vote is nothing but certifying the block.